In the last segment, you'll have to forgive me on this table. I changed my mind midstream about the lead, and then I did this so fast I put my number in the wrong place. So I've got 32 sulfur, 33 sulfur, and 32 sulfur. So sorry. All right, so 82 protons, 16 protons. Okay? The number of neutrons, these are all the same because there are no isotopes. What we have here are ions. These are the ions for lead. Okay? So as we go from neutral to +2 to +4, okay, neutral, protons equal electrons. +2 means we lose 2. +4 means we lose 4. Down here, these two are my isotopes. Okay, so these two are the isotopes. 16 neutrons, 17 neutrons. Okay? It's these two that are the ions because this is neutral, this is now charged. So I start with 16, I end with 18. So you could imagine that if this lead here is giving up 2 electrons, so I'm going to go back to my pencils, okay? So my right hand is the lead. It's got these 2 electrons. It's going to lose. My left hand is going to pick these up. Okay, so my right hand is going to lose them. My left hand is going to gain them. That's how we get a transfer. Okay, so we lose, we gain. All right, we'll come back to this idea of 4 here in just a minute. All right. Now, segment 5 begins with the modern model of the atom. We can't just have a nucleus with our protons and our neutrons and our electrons just out here. It just doesn't work. And the reason for that is that if our nucleus is plus and our electrons are minus, what do we know about pluses and minuses? They attract. So if we have a plus in the nucleus and minuses out here, over time, the electron will just spiral right into the nucleus and we will simply have a nucleus. And what this means, the outcome would be that the electron would spiral into the nucleus, and this is very, very bad news. Okay, this is really, really bad news because the reality of it is if this is your atom and this is your nucleus, which is really, really small, basically you have an atom with no volume. This is really, really bad news because the atom makes up everything in the world around us. It makes up people, it makes up the earth, it makes up the sun, it makes up the solar system. So you can't just have protons and neutrons in the nucleus and electrons out here. You can't do that, okay? Now, where the electrons are is really beyond the scope of this course. It is very, 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 very complex. Okay, but that notwithstanding, I will do the best I can to help you through figuring out where the electrons are. Okay, the bottom line is that the location of the electron is based on the fact that E equals hc over lambda equals h nu. All right, so these are a lot of symbols. E is energy. H, so there's 2 of them here, and C are constants. H is something called Planck's constant. C is the speed of light. Lambda is wavelength. Nu, it's like V with a tail. Okay, V with a tail is frequency. And so what this means is that there's a relationship between energy and wavelength. If something has a wavelength, it has energy. So I'm going to rewrite this because this didn't come out in my notes very well. Okay? If something has a frequency, it's going to have energy. And we know this to be true, right? If you hear something really, 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 really super loud, doesn't that have some energy? It sure does. Your wavelength, if you're standing in the ocean or you're standing by a tsunami, doesn't that have energy? Of course it does. You sit under the sun and it's warm and you absorb that sunlight. Isn't that energy? Yeah. And the upshot of this is that the location of the electron has to do with energy. Energy, 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 energy. Okay? Now there is a huge, 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 huge math model that was developed on this. And this is way beyond the scope of what we can do in here. It has to do with multivariable calculus and psi wave equations and all kinds of things that boggle the mind. Okay? But I'm going to pare it down into as simple a thing as I can get for you. And this energy model boils down into 4 quantum numbers. And the quantum numbers are like an address. And the basic idea is shown in a Bohr model. So a Bohr model will have our protons and neutrons in the nucleus. And then it will have these energy levels. N equals 1. N equals 2. N equals 3. N equals 4. N equals 5. N equals 6. N equals 7. Okay, so you can pretend I drew those all around. N equals 7 is as far as we can go. Okay, so N is called the principal quantum number. And it's analogous to energy. So as N increases, the energy increases. So N equals 1 is the lowest energy level. Then it goes up, 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 up until you get to N equals 7, and that's as high as you can go. Okay? Now you can think of these as being like streets. And within the street, like if you live on First Avenue, you could have an address. So you could have like 1, 2, 3 First Avenue, anywhere city, anywhere state, 1, 2, 3, 4, right? And the more numbers I give you, the more likely you are able to find where that electron, quote unquote, lives. Okay? Now, the other 4 quantum numbers, in case you care, are M sub L, and S, and it's beyond the scope of what we want to talk about. But the upshot is the location of the electron is an abbreviation to these 4 numbers, N, L, M sub L, and S, which describe the basic shape of the areas where the electrons are likely to be. Okay, that's code for probability. So oftentimes when I do this, if you think of these as addresses, you can think of them as like roads or houses. So you can think, for example, cars. Types of cars. You could have a Mini Cooper, you could have a Ford Ranger, you could have a Hummer, you could have I don't know cars very much, a Honda Fit, that's what I drive, okay? There's a bunch of them. You have the same vehicle, they just come in different shapes, different sizes, and they drive different directions. Okay, now these descriptors, okay, are called orbitals. The orbitals is the address described by these 4 quantum numbers, and it's an area of probability of finding the electrons. So what this means then is the location of the electron is based on probability. It has to do with energy changes, and the places we find electrons are called orbitals. Okay, and then this one is based on one of these 4, which is actually M sub S, okay, which is magnetic spin. And what this tells us is the orbitals can only have 2 electrons regardless of the type. So the analogy is, regardless of whether I have a Mini Cooper, a Ford Ranger, a Hummer, or a Honda Fit, I can only put 2 electrons in it. Only 2. If I have a school bus, only 2 electrons. If I have a unit train, 2 electrons. A unit train has 1,000 cars, okay? If I have a 747, 2 electrons. And with there, we'll pick up on the next segment.